Okay, here in this unit, we're going to continue looking at heredity. However, so far we've just focused on how we can determine the probability that one trait will be passed on and how that one trait can be passed on from parents to the offspring. So we've just focused on monohybrid crosses, crossing one trait. So in this section, we're going to be looking at dihybrid crosses, di meaning two. So we're going to be looking at what the probability that two traits that could be linked together can get passed on. It's the same process, the same concept. You're just doing a larger Punnett square to see what the results would be. Before we get started on looking at dihybrids, just quick review. Don't forget, monohybrid, just one trait. Okay, here's an example if you wanted to work it. You should be good with how to do one trait or monohybrid crosses. Remember that anytime you're looking at the genotypes, okay, two lowercase letters would mean it's homozygous recessive. Two uppercase letters would mean that it's homozygous dominant. And then remember, if there's one uppercase and one lowercase, then you're talking about heterozygous. That still applies to dihybrid crosses. Okay? Once again, this is just a little review. If you wanted to look through it and work the problem, you can. However, we just covered monohybrid crosses, so we're going to go ahead and get started with looking at dihybrid. So like I mentioned, di means two, so we're crossing two traits that are usually linked together and looking at the probability that what offspring would get what two traits. Okay, so we're looking at two traits now, not just one. So some of our examples from last time, we did fur color for rabbits, white fur color versus brown fur color. Okay, we're just looking at one trait and looking at what probability would the eye color be in the different offspring, or excuse me, the coat color be for the different offspring. Okay, so in this example, we're going to be looking at not only fur color for the rabbits, whether it be black fur color or white fur color, but we're also going to be looking at the coat texture, the texture of the fur. Is the fur going to be smooth in texture when it's touched, or is it going to be rough in texture? So these are going to be two traits that we're going to cross together, because usually, or sometimes you can find traits like this that could be linked. So for example, if whatever color the fur that the offspring gets, they would usually get either a rough or smooth coat that goes along with it. So what we're going to do is we're going to cross two heterozygous individuals. Okay, and here are the genotypes down here. So here's the first genotype for the first parent, and here's the second genotype for the second parent. So here is mom and here is dad. They're both heterozygous. Okay, so heterozygous for fur color, heterozygous for coat texture. Okay, we've got to figure out all possible gametes before we can get started, so we can plug those gametes into the Punnett square. Since these are our genotypes from both parents, each gamete for the Punnett square, each section for the gametes for the Punnett square must have one B and one R for each section. Okay? So let's look at the possible gametes. You have to have one B and one R, so we can have a big B and a big R. Another gamete pairing could be a big B and a little r. Then you can get a little b and a big R, and then a little b and a little r. And since they're both the same as far as genotype, this gamete pairing would be the same for both parents. Okay, now we're just going to put them on the dihybrid cross, the Punnett square for the dihybrid cross. So here we go. Notice that the Punnett square is a little bit bigger Because remember, now we've got 4 possible gamete combinations from each parent because we have 2 traits that we're crossing at the same time. So we're going to have 16 possible outcomes as far as the arrangement of these gametes goes. So here we go. Remember, the capital letters go first in the arrangement, and then you always put the same letter together. Okay. So when we start this, your first box here, you'll have big B, then big R and big R. Your second box, you'll have big B, big R, little r. Your third box, you'll have big B, big R. And then your fourth box on the top, you'll have big B, big R, little r. Okay, and you will do this every row. So you'll use this gamete arrangement with this one for the second row, for this box, and so forth. Okay, here it is filled out. Remember, the B's, the same letters stick together. Okay, and then within that arrangement, the capital letters go first and then the lowercase letters. So when we get all the way down to here, we look at the last row now. We got big B and little b, and then big R, little r. So that would be our gamete arrangement, or our genotype arrangement for that one. Then you could get big B, little r for this one, and so forth. So what we've done is we've set up a Punnett square, and we've crossed 2 traits that could be linked together, okay, during fertilization. And now we can see the possible outcomes. Okay, since there are 16 boxes, we just have to look and see how many per 16 boxes you would have that are the same. So for example, this last box here, it is homozygous recessive for coat color and for coat texture, and this is the only one that's like this. So there's a 1 in 16 chance. Okay, there's a 1 in 16 chance that a baby will be born with that genotype. Whereas if we did, say, this one with the homozygous dominant coat color and heterozygous fur color, there's 1, 2, that would be it. So there's 2 in that example, so it would be 2 out of 16, or you could reduce that. So you can see how it's a little bit more detailed, or a little more complex, because it's just a little bit bigger of a Punnett square, but it has the same concept of how the traits get linked together. Okay, so now that we've got our cross of our 2 traits, let's look at what the possible outcomes are. So for the first question, let's try to figure out what's the probability that you're going to get, what number would you get of black fur and a rough coat. Let's see if we can figure out how many could be born from this cross that have a black coat or a black fur and a smooth coat. How many would have white fur and a rough coat, and then how many are going to have white fur and a smooth coat. Okay, remember, black is dominant, black fur is dominant, rough coat is dominant. Here you have black fur, which is dominant, and smooth coat, which is recessive. Here you would have white fur, which is recessive, and rough coat, which is dominant. And then the last thing that could pop up would be white coat, or white fur, which is recessive, and smooth coat, which is recessive. So we're going to try to figure out the phenotype ratio. Okay? And you're always going to set it up this way. You're going to set up a phenotype ratio, the first number being dominant trait, the second number being dominant recessive, then the third number, how many are recessive dominant, and then the last number being how many are recessive recessive. So you're going to have 4 numbers in the phenotype ratio. But let's figure out how many we have for each one first. So for the black fur rough coat, this dominant, okay, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's going to be 9 of those. Dominant trait. How many are black coat, fur smooth coat? So that would be dominant recessive. So 1, 2, 3. So that would be the dominant recessive trait. How many are going to be white fur rough coat? So recessive dominant. That would be 1, 2, 3 that are recessive dominant. And then the last how many would be recessive? How many are going to have the white fur and the smooth coat? And there's just 1. So now our phenotype ratio is going to be 9, 3, 3, 1. Okay, here's some more practice. Okay, we went over these in class, but if you want to practice them a little bit more, you can. But if you have questions, make sure that you go back and review what we just did with that first example. Okay.